Hello everyone, this question is about differentiation. The equation of a curve is x squared y minus ay squared equals 4a cubed, where a is a non-zero constant. Part A show that dy dx equals 2xy over 2ay minus x squared, 4 marks. So this is using implicit differentiation. So you just rewrite this equation like this, exactly the same, and then you differentiate both sides with respect to x or y. Here we differentiate both sides with respect to x, and when we differentiate x squared y, because this is a multiplication, we have to use the product rule. So if y equals uv, the y prime is u prime v plus v prime u. So let's say the u is x squared and the v is y. The u prime is the derivative of x squared with respect to x. So just as usual, it's just 2x. This is u prime. The v is the y, rewrite. And the v prime is the derivative of y with respect to x. So it's not just 1, but it's actually 1 dy dx. This is v prime. The u is x squared. Rewrite the x squared. Now, when we differentiate the ay squared here, we get, as usual, bring the power down. So we have 2a y, the power is now 1. But again, because different letters, implicit differentiation times dy dx, don't forget. So now we have 2xy x squared dy dx minus 2ay dy dx equals 0. And from here, do the algebra, factor out dy dx, and then divide both sides by x squared minus 2ay. And from here, if you need to get what you wanna prove, we can just multiply by minus both parts of the fraction. So we're gonna get positive 2xy over 2ay minus x squared, which is what we need to prove. Okay, now the second part. Hence, find the coordinates of the points where tangent to the curve is parallel to the y-axis, 4 marks. Okay, so we don't know what the shape of the curve is. Let's say this is the curve. So we need to find the coordinates of points on the curve such that maybe around here, let's say, or somewhere, let's say the curve is like this. So around here, the tangent line is a vertical line because parallel to the y-axis, so it's a vertical line. So we need to find the coordinates when the gradient is undefined. Okay, so the coordinates of the points where the gradient is undefined because it's a vertical line. Remember, horizontal line gradient is 0, vertical line the gradient is undefined. So undefined, of course, this means it's something, we don't care, divided by 0. That's how the gradient can be undefined. And gradient is basically dy dx. So what we need to find is, when is the dy dx undefined, which means when the denominator of the dy dx is 0. So now, previously we know the denominator is 2ay minus x squared. So we are solving 2ay minus x squared equals 0. So if you just move this minus x squared to the right, you're gonna get positive x squared, and then you divide both sides by 2a, you get 1 over 2a x squared. And previously we have the curve equation, x squared y minus ay squared equals 4a cubed. So you rewrite the original curve equation, and now you substitute this y here and here. So this is the y, this is the y. So If you simplify, you get 1 over 2a times x to the fourth, and here if you square everything, you get 1 over 4a squared x to the fourth, still multiplied by minus a. And if you factor out the x to the fourth, you get 1 over 2a minus, this is actually just 1 over 4a. 1 over 2 minus 1 over 4 is 1 over 4, so 1 over 4a times x to the fourth, and then you multiply both sides by 4a, so you get 16a to the fourth on the right, and then you take the fourth root. Don't forget plus minus because it's an even power. The fourth root of 16 is 2, the fourth root of a to the fourth is just a, and the y, just substitute here. The y is 1 over 2a times x squared, so we don't care which one we use, plus or minus 2a, but the square is always positive for a squared. So the y is always, after you simplify, the y is just 2a, whatever the x is, which means we have two possible coordinates when the x is negative or positive 2a, but the y is always 2a, so we have two coordinates for the final answer. Okay, I'll see you again next time.